Hi, my name is NURUL BINTI and my MATRIC ID is SITI21104. For the dataset that we choose, which is US electric vehicle population data, and today our group would like to present our project. For my part, I will explain about the objective. The dataset is based on the US electric vehicle populations, and the following objective can be identified as a result of the dataset's creations. So basically, this is our objective. The first one is to analyze the dataset taken from the Kaggle website, which are electric vehicle types and electric range as input and clean alternative fuel vehicle eligibility as output. Second objective, which is to develop a fuzzy logic model that accurately predicts clean alternative fuel vehicle eligibility based on electric range and vehicle type. Next is to identify key factor and threshold within electric range and vehicle type that influence clean alternative fuel vehicle eligibility. The last one, which is to compare the fuzzy logic model's prediction with actual clean alternative fuel vehicle classification to assess its accuracy and reliability.
My name is Nursyafika binti Kamal, MATRIC ID CD22020. Now I will present about attribute, which consists of input and output. In this project, we will create a fuzzy logic function for the specified dataset representing the population of electric vehicle in the United States. Several relevant inputs are discovered and output is obtained from the input. There are two inputs. Firstly, electric vehicle type (EVT). The electric vehicle type that is used in this dataset includes battery electric vehicle (BEV) and plug-in hybrid electric vehicle (PHEV). Secondly, electric range (ER). The input range from 0 until 337 is based on the distance the EV may travel without its battery needing to be recharged or changed. The ER is considered as low when the electric range is in the range of 1 until 30. The ER is considered high when the electric range is 31 and above. Meanwhile, if the value of ER is 0, it is reflected as unknown. For the output, clean alternative fuel vehicle or CAFV eligibility is derived from the input parameter of electric vehicle type (EVT) and electric range (ER). These factors play a crucial role in determining whether a vehicle qualifies for CAFV program, with the type of electric vehicle and its range being key consideration. The interplay between these input variables influences the eligibility criteria for clean alternative fuel vehicle program in various regions.
My name is BATRISYIA. My MATRIC ID is CD21098. I will be presenting methodology and conclusion. Let's start with the methodology. This figure shows the fuzzy logic system for our group, where electric car information, electric vehicle type, and electric range act as the fuzzy input set, and clean alternative fuel vehicle (CAFV) act as the fuzzy output set. Let's move on to the fuzzification. In the fuzzification module, we transform the system inputs, which are Cripps number, into fuzzy sets. In our case, we convert Cripps input values, which are electric vehicle type (EVT), PHEV, BEV, and electric range (ER), unknown, low, high, into fuzzy set using membership function. We have applied appropriate membership function for each linguistic value of EVT and ER to generate fuzzy set for each input variable. As for the defuzzification module, we transform the fuzzy set obtained by the inference engine into a Cripps value by combining the firing strength of rules using fuzzy operators, which is OR. We have converted the aggregated fuzzy output set into a Cripps output value to obtain the final decision regarding the clean alternative fuel vehicle, eligible, unknown, and ineligible.
Okay, now we're moving on to the explanation of the coding to produce the membership graph. So first, we need to import the package that we needed. And here, we upload the Excel file which is contain the input and output of the data we have chosen. And then here, the system will read the file that we uploaded. We have EV type as the input, CAFV as the output, and electric range as the input. So next, here we define the universe of the input and output. And then here we set the membership function of the input, which is this is the input 1, this is for the input 2, and this is for the output. And then here we put the fuzzy rule, and then create the fuzzy control system here. And then this is the membership function of electric range. We have low, height, and unknown. This is the low line, this is the height line, and the unknown line is here because the data is 0, which is the membership is 0. So it will be on the line at the x-axis. And then next, this is the electric vehicle type of membership. This one is for BEV, and then this is for electric vehicle type. And then lastly, this is the membership function graph for CAFV.
Fuzzy logic rules, rule based. If EV type is BEV and ER is low, then CAFV eligibility is ineligible. If EV type is BEV and ER is high, then CAFV eligibility is eligible. If EV type is BEV and ER is null, then CAFV eligibility is unknown. If EV type is PHEV and ER is low, then CAFV eligibility is ineligible. If EV type is PHEV and ER is high, then CAFV eligibility is eligible. Lastly, if EV type is PHEV and ER is null, then CAFV eligibility is unknown.
So the next part that I will explain is for the classification result, where I use the coding Python to test the output. The first one is I enter the input for electric vehicle type for battery electric vehicle, and for the second input is for electric range, which is 29, and the graph output show that the clean alternative fuel vehicle is on the ineligible side. The next data that I test is EV type for battery electric vehicle, while electric range is 0, and the output show that the clean alternative fuel vehicle are on the unknown. While for the third data, I choose for electric vehicle type BEV also, which is battery electric vehicle, and electric range is 250, and the output of the graph show that the clean alternative fuel vehicle are on the eligible side. The next data that I test, which is for the electric vehicle type for PHEV, which is hybrid electric vehicle, and the electric range is 0. Same goes to the output for clean alternative fuel vehicle, show that the output are on the unknown because of the electric range is 0. Next is for electric vehicle type for PHEV hybrid car, and electric range is 25. It shows that the clean alternative fuel vehicle output are on the ineligible side. While for the last data that I test, which is for electric vehicle type PHEV hybrid, and electric range is 72, and the graph output show that the clean alternative fuel vehicle are on the eligible side. So I can say that based on our output, we are able to see the difference between the real output and fuzzy logic output, that there are the 100% accuracy between these two outputs.
Okay, now we are moving to the next part, which is classification accuracy. So at this classification accuracy, we need to determine whether our calculated output is accurate or not. So this is the classification accuracy. Here we pick some random data, and then we do some calculation to produce output. So the data we choose here is BEV 29. We do the calculation, and then the output is 84%, which is accurate because it is higher percentage. While another one data we choose, which is BEV215. We do the calculation and the output we get is 37%. So it is lower. So we can conclude that some of the data we calculate is accurate and some of them is inaccurate.
Now we meet again to discuss about the last part of this video presentation, which is conclusion. We are delighted to inform you that the fuzzy logic system we designed achieved an accuracy of 100%, showcasing its potential for reliable clean alternative fuel vehicle CAFV eligibility using the dataset, which a total of 1,100 US electric vehicles upon completion of each phase of this fuzzy logic project. With the evolution of this technology, we can achieve driving future advancement in clean transportation initiative by offering an accurate tool for assessing CAFV eligibility. Our system can inform policy decisions, guide engineering improvements, and ultimately contribute to a greener future. That's all from our group. Thank you.